from USM. So today we have we have few speakers that will be talking on the AI for urban mobility. This event is happening thanks to Royal Academy of Engineering UK with partnership from Penang Institute, SPI, and also ASI. Yeah. So before we start, there are several housekeeping items that I would like to highlight. So this session will be recorded and it will be made available in our YouTube channel in a week's time. So, and at the end of the session, we will share a survey form. So do submit the feedback form if you would like to get the e-certificate, because we have participants who always ask that. Yeah, and if you have any questions to the panelists during the session, there's a Q&A box at the right-hand bottom. So do pose your question if you have any directly either to the panelists or to everyone, and I will moderate the questions. So without further ado, I will introduce our panelists for today. So we have Dr. Susilawati joining us from Monash University, Malaysia. She received her master's and doctorate degree in transportation engineering from the University of South Australia in 2007 and also 2012 respectively. Before joining Monash, she worked in MNC's firm as a geospatial data analyst in Indonesia and Australia. Her research interests are mainly on dynamic transport planning and modeling that consider the static nature of traffic demand and road capacity to measure travel demand management effectiveness, including congestion charging, and create reliable transport system. She has been working on various projects to evaluate the effect of AV, autonomous vehicles, and also share autonomous vehicles adoption on public transport's first mile and last mile connectivity, and the in-vehicle value of time and schedule delay. She's the PI for 2 FRGS grants on sustainable and intelligent transport, and co-PI for several multidisciplinary projects on smart cities and active mobility. We also have Leila joining us from Denmark. She is a technical advisor with over 10 years in project management at an international level. She's also a co-founder of ASI Gulf, an experienced engineer in the field of transportation, engineering, project management, and compliance with over 10 years of combined experience, including strategy and mentoring. And as part of executive management team, Leila is a passionate advocate for efficient and safe transport system. She works on advanced technology and disruptive tools such as drones, AI sensors to improve safety and prevent traffic accidents. She is experienced in combining existing knowledge with new methods to proactively uncover new information. So joining us from SPI Portugal, we have Sarah, Dr. Sarah Medina, and also João Medina. Dr. Sarah is a member of the board of SPI, an international consulting group with offices located in Europe, North America, Asia, and also SPI Venture. Dr. Medina contributes to the overall management of SPI, being responsible for managing SPI activities and services in China since 2004, as well as in the Southeast Asian market. She has coordinated projects for public and private sectors clients in Europe and around the world, including projects for international organizations in innovation management, technology transfer, R&D, internationalization, sector studies, establishment of partnerships, and policy development. She also manages projects funded by the European Commission, the World Bank, and Inter-American Development Bank. Dr. Medina is an expert in international committee members for International Technology Transfer Network, in which she promotes international technology transfer and innovation cooperation in China. She is also an expert evaluator for European Commission Horizon 2020 SME instruments. She also collaborates with Eurostars as an expert evaluator of Eurostar applications and as an expert panel member of the ex-post impact assessment of Eurostar 1. John Medina, also from SPI, is an experienced consultant having developed numerous projects for public sector, private sector, and international institutes around the world. Working in SPI since 2000, Mr. Medina manages the urban and territorial development team of the company. He coordinates projects covering a wide range of areas, including regional development, innovation, smart specialization, smart cities, urban renewal, urban development, tourism, climate change, social inclusion, housing, clusters development, entrepreneurial ecosystem, business incubation, among others. By having based in Angola during 2009, in China in 2007, and in US in 2000, and by having developed several consultancy projects in countries such as Brazil and Mozambique, Mr. Medina acquired an extensive international experience and proved ability to adapt to multicultural environment. So we'll start with by discussing about technologies. So in the past, when we talk about urban mobilities, technology will actually have been creating a very high impact where people talk about connected autonomous vehicles. So the question is, will autonomous vehicles eventually play a key role in multimodal urban mobilities? So I would like to invite Dr. Susie to share your thoughts and also the roles of AV for smart city initiatives.
Thanks, Dr. Chong. Let me share my screen. Yeah. So should be available now. Yeah. See? Good?
Yeah, good.
Start from here. Okay, good morning, good afternoon, good evening, everyone. So thank you for joining us today in this excited presentation. I would like to also thank Dr. Chong and the team for the invitation to to allow me to share my work and my research in the area of the autonomous cars for the Smart City Initiative. So let me just introduce where I'm from. Actually, I'm academic staff from Monash University, Malaysia. It is situated at Bandar Sunway, around 50 kilometers away from Kuala Lumpur, for those of you who's not from Kuala Lumpur. So it only takes about less than half an hour from Kuala Lumpur to reach our campus. So it's established in 1998, and it can be considered as a third largest of Monash University campus. And then it was the first foreign university campus in Malaysia. We have around 8,400 students from 78 different countries. And currently, Monash University ranked 57 and 58 in the world according to the Times Higher Education and QS World University ranking. So let me go back to the question or the discussion that we will be going to highlight today. Autonomous vehicle for the Smart City Initiative. Why we need to incorporate or to talk about a smart city, because the rising of the urban challenges, urbanization. In 2050, it was expected that 70% of the population will be in urban area, and that it creates some problem to the urban mobility already. And then we know that we have a limited resources, and then recently, due to the technological breakthrough, that able us to collect more data, to be connected, then that's the idea of a smart city rise that can be defined as using information and communication technology to enhance livability, workability, and sustainability. So coming back to the pillar of the smart city, it has the 7 pillars, including smart people, smart government, smart economy, digital infrastructure, and also smart living. Not to miss the point of a smart mobility that allow us to provide safe, seamless, efficient, and connected mobility through the integration and providing reliable mobility service. So looking at the urban mobility problem in Malaysia, unlike like a major city in the world, cities in Malaysia also experiencing problem. So it was estimated that around 10 to 20 billion of congestion costs due to the fuel consumption, loss of opportunity. And then according to the news study, it says that 1 car in Malaysia for every 2.25 people. It also suggests that 1 motor vehicle for 1 people in Malaysia. And then the disconnected between land use and planning create urban sprawl that contribute to the first mile and last mile connectivity issue. A lot of initiative has been done in Malaysia to tackle this kind of challenges. And then recently, Malaysia government already, introduced a lot of new initiative, including the autonomous vehicle proof of concept. So this is the point that I would like to fill the gap that the group or the research group that we have in Monash, Malaysia would like to fill the gap in terms of how the autonomous vehicle can, support this the smart city initiative. We know that autonomous vehicle have a sensor that allow it to sense its surrounding and then to generate or to develop trajectory planning. Then it doesn't need it needs a little to know human control. A lot of discussion about the benefits and the problems of EV. It's contradict to each other actually. And then at the moment it's still a bit controversy. Some people believe that EV will have to reduce the congestion, but some people say that EV will compete with the public transport and also active transport. At the same time, we know that due to the shorter headway of the EV can really help us to increase the capacity. That's where I'm going to discuss in the next slide. That's where our research also lies about in the how the EV can reduce can increase capacity and reduce the congestion. At the same time, because EV doesn't need to have a space to park, it can be keep moving around. So that also a discussion about the EV benefit in terms of reducing parking costs. Then this is some activity that we did in Monash, Malaysia. Particularly, we are a team of multidisciplinary team, come from mechatronic engineering, mechanical engineering, and also transport and traffic engineering. What we're looking at as is actually the benefit of EV in terms in the point of view of transport and traffic engineering, not necessarily as a physical EV, because at the moment we don't have physical EV. Even in Malaysia, as far as I know, that currently Malaysia like to have the demo for EV as well. It's not open for public yet. So when we look at an EV and how EV can increase the capacity, is actually depending on the headway, which is the distance difference between 2 consecutive vehicles. And we know that when the EV is available, it's not going to be 100% in the network. It's going to be, there is a transition period where EV will mix with HV. That's also, attract interest from the researcher to look at how the EV interact with another EV. At the same time, how EV interact with the road user. So I think in the next presentation, Leila will talk a lot about how EV interacts with the road user in terms of safety, and also perhaps Sarah and the team will talk about more on the regulation as well. So come back to what the research that we did, we've done in Monash, Malaysia, is looking at this capacity. So on the right hand side, it shows that the increasing of the EV penetration rate on the road network will increase the road capacity. That help us to also lessen the congestion. At the same time, we also look at how EVI can change the way we make a trip, or we plan a trip. So what does it mean of planning a trip? So whenever people would like to visit one particular point from point A and point B, there are a lot of decisions that you make. What time should I leave? What mode should I take? Which road that should I select? So that's what we call it trip planning. So when EVI is going to be available, people can do something else because they don't need to, they don't need to worry about what is the environment. They don't need to focus on the road. Instead, they can do something else. I'm talking about the EVI at the higher level, perhaps like EVI level 4 and level 4 and level 5. As we know that EVI have a certain level from level 1, 2, and 3. But now I think my research focused on the higher level where EVI need a little human input. So when people write the EVI, so then they can use their time on something else. So then the value of time will change, and also the schedule delay. So that's trigger my curiosity, and then continuing doing on this project at a different scale. So now we are talking at the macro scale. So we also looking at how the perception of Malaysian toward EVI, because we know in many countries there is a discussion about the safety issue and regulation issue with safety. When we collect a data and looking at the collecting the perception of EVI, it turns out that almost in almost across the age group, that people are aware about EVI and are willing to adopt that one. And then also whether they are in the different technology adoption, whether they are early adopter or late adopter. So it gives us confidence when the technology are ready and also the infrastructure are ready. So then EVI can be, gradually can be adopted. But then the funny thing is, this is in relation to the EVI competing with the public transport and also active transport. We found that when we increase the working time for riding a EVI or SEVI, people start to going back to their driving alone, where they prefer their own car. So this is something that we can continue to study to fill the gap. At the same time, when EVI is available, so it's not necessarily EVI is belong to one person. EVI can be shared. Then it can promote what we call it shared autonomous vehicle. In this study, what we're looking at is actually what if scenario when EVI is available and it can be shared. So the figure on the left, it shows the station coverage, the coverage of each LRT and MRT station in Kuala Lumpur, and then the blue dot showing the coverage. It's very limited coverage because people only willing to walk up to 800 meters to reach the station, and then beyond that, people wouldn't like to walk. So then we need to fill some gap. So you can see in between there is a gap. So what if the scenario, if we provide an EVI, and then what the connectivity increase? What is the accessibility increase? And then what is the impact to the existing road traffic? So you can see on the left-hand side is another figure to show that the increase and decrease of the traffic volume after introducing a shared EVI in certain area in connecting two main public transport like MRT and LRT. So it's quite interesting to look into this direction as well. Again, if we would like to promote the shared autonomous vehicle, it must be, through the adoption of smart cities, smart technology, IoT, and so on. So this is also to show the audience today that what the other study that we did to create a smart city prototype. So what we call it prototype, the infrastructure and the vehicle are communicating each other through the cloud data processing, and then assign vehicle to pick up passenger, and then send the vehicle to the passenger to to their destination. At the same time, to encourage of sharing, we develop a kind of a reward point that can be utilized by the rider and also the driver. And then from that point, we can assess how much we can reduce the CO2, how much we can reduce the fuel consumption, and then what is the average waiting time for each regular vehicle. So it just to show that, through the collaboration and also the technical breakthrough, we can adopt this kind of agenda or initiative in the smart city concept. Another one in relation to the AI and machine learning, we also look at in the optimization of the shared autonomous vehicle, particularly in which location that we need to put the station. This is very important due to the behavior of the people, because people doesn't like to walk too far from their destination and their origin and destination. So we evaluate the data from the Grab data, we call it Grab Posisi data, consisting about close to 60,000 trips in Jakarta, and then looking at the temporal and spatial and temporal variation. So you can see on average the trip date, the trip time or the travel time or the trip times of each trip is around like between 15 minutes to 20 minutes. It's a very short one actually. I think we also have we also observe data in Singapore. Unfortunately, we don't have data for Kuala Lumpur, which is if we have that one, it's going to be very interesting to see that one. And then we see from this, spatial temporal variation, we can create or we can generate a routing strategy, again, to optimize the travel time. So we can see that the travel time between optimized and unoptimized. We use a lot of optimization algorithm, including the genetic algorithm and also the N-colony optimization to create the routing strategy for this on-demand mobility on-demand for routing strategy. Okay, so I think that's what we did, what we've done in Monash, Malaysia, but we know that it's not enough. So it's a lot of things that need to be done through the collaborative research that involve a local council, government from Ministry of Transport, Midtrans, MyROS from the road safety part, and also from the industry. So everyone needs to play a role to promote this smart city initiative, and then to get a fruitful benefit from the technology, the capability offered by AV. So I just put some takeaway message for us for further discussion because we only have 15 minutes. But the presentation today is for me to give exposure to everyone today, to encourage a collaboration and also to look for other opportunities, and at the same time to also encourage or to pass a message to the government as well to make their data open and centralized data. I think that's a very important. When we talk about AI, data is one thing. We need to have millions of data to come up with a good model that can help us to to make a good decision. And then one discussion that I recently joined in ITS Australia, when we talk about AI for transport and traffic, it must be tailor-made, because transport and traffic consists of human, and then human have behavior, and then it's really make the AI algorithm more complicated, and that's why we need to have what we call it a tailor-made AI for transport and traffic. Thank you so much for listening for today's presentation. I'm happy to for further discussion. And yes, thank you.
Okay, thanks, Dr. Susie. Yeah, it's very interesting work that you have done. So you talk about how AV can increase efficiency, reduce traffic congestion, reduce greenhouse gas emission, and also you did provide an introduction about the safety, which right now I would like to invite Leila to share on your thoughts, how AI can assist in transportation safety. Leila?
Yes. Can
Yeah.
you see me? Can you hear me and see me?
Yes.
I hope. Yes.
Yes. Good.
Should I start now or?
Yes. Yes.
Yeah. Okay. Hi, everyone. Thank you very much for being present today. And first of all, I would like to share a big thanks with to the University of Science Malaysia for making this webinar possible and for facilitating it. It has been a pleasure so far. As I've been previously introduced, my name is Leila. I'm the founder of ASI.gov. I'm originally from Portugal, and in the last 12 years, I've lived, worked, and studied in different European cities. And currently, I'm based in Denmark. ASI.gov has been founded to help prevent transportation accidents more efficiently. And today, I will be, or perhaps us, be discussing on a number of factors. So before we start, I would like to just ask you a question. I mean, to the audience. I am sharing here the Mentimeter code, and I don't know if we can share on the chat with everyone. And I would like to hear your views on the following question. Which of the following you believe to influence transportation safety the most? Technology, humans, regulations, perhaps the transportation environment, or others. And I guess that we will be seeing the results later on.
Yes, I will share
Is
the results later. So for the participants, the link is being shared in the chat. So do click on the answer that you think fits you. Yeah, and we will share it later.
Okay, so we continue. Right, at ASI.gov, we are a diverse team of professionals, and our areas of expertise include engineering, business management, social psychology, and communication. The current approach we undertake on traffic safety studies is delivered by gathering data in the form of qualitative and quantitative research, engage with stakeholders from the local and regional authorities' perspective to the road users experts, which means us, and disseminating the information in the form of training, education, awareness campaigns, and so on and so forth. And this, according to previous studies, there are three key elements that affect transportation safety: human, the infrastructure, and the environment. At our approach, we take the human factors at the core. And in addition to that, we adopt advanced technology to assist the applicability of our approach. Right, this is an illustration. Apologies for just running off, showing the full show. Going backwards, one more slide. Okay, so this is just for an illustration of an exercise. It's actually an observation of a particular junction that we conducted as an experiment study, where we took into account the behavior of the road users in a reality, a real case. So this is more or less the patterns that the psychologists that run this exercise could conclude. And the benefit that this can bring into is that in some occasions we give an impression that we behave in a way. We mentioned the human aspect, the human behavior, and realistically we demonstrate a different behavior. And the reason why this takes a very important aspect is the unpredictability that it brings along. The closer we become to develop the infrastructure to the human behavior, the better the service will become on the long term. So here I just share with you the perspective of qualitative research, where we more in depth analyze the psychological, the cognitive behavior of the pedestrians, and in conjunction with the interviews and focus groups of the stakeholders and the road experts respectively. On the next slide, I'll be sharing the second perspective, which relates to the infrastructure. I'm having some problems here, so apologies with the... Okay, so here I'm sharing the same behavior of the same... Okay, so here I'm sharing the infrastructure. So on the first phases, we took into account the human factors. In the second stage, we will see the response of the infrastructure to the same behavior. And from here, we have an opportunity to assess the applicability or the feasibility of the infrastructure that has been implemented in a particular environment. But it's important for us to understand, like Susie previously mentioned, that the areas will change accordingly to the road users. So if we are, for example, based in an environment where people use more motorbikes than bicycles, in comparison to the use of pedestrian facilities, these patterns will change. And that is when this assessment becomes close to the case study related. So in this case, we could see that the cyclists were overtaking and taking different journeys based on the facilities that have been provided to them. And that is when we come along and suggest considerations for perhaps different recommendations based on the behavior of the pedestrians. This is also a preparation to introduce additional information into a model that could be incorporated perhaps in the autonomous vehicles or in a local or regional authority, and also consider the cost and benefit estimation for the long term. The communication is adopted to drive strategic messages to the role players, the key role players that take into place the regulations that perhaps Sarah will mention later on. And this is going to give us an opportunity for us to make a more close to the needs of the road users, the stakeholders, and improve the safety alongside. And here, next, I'm just happy to share the extracted knowledge from the examination that we conducted. So the permanent speed limits were in that location at 30 kilometers per hour. The road was apparently dry. It's also suggested that the further assessment could be conducted. On average, the pedestrians were more present between 9 and 10 than in between 10 and 11, and this could be also connected with the traffic congestion aspect, and the road users spec that we observed are also presented below. And here, as I previously mentioned, I have just an introduction of mid-long-term considerations. I wouldn't say recommendations, considerations that we could perhaps have in that particular intersection of perhaps considering to introduce a roundabout for an intersection with more than 6 arms on a long term, and in the midterm introduce bespoke and bicycle lanes, perhaps even on a more immediate case, considering markings on the floor, and also consider, with respect to speed limits, variable speed limits according to the time, as the speed limits is a very important aspect. It is proven that from 30 kilometers per hour onwards, the likelihood of an accident leading to a fatality, it's much higher than, I would say, 8 times higher, according to previous studies, than compared with the 20 kilometers per hour. And also establishing other types of calming measures is also a consideration that has been suggested. This is an overview to share with you. As a stage, as an iterative stage that you take a pre-feasibility approach, so assessing the market research, consider the user center since the roads will be developed for the road users, and establish the goals and the mid-long term vision. The advisory comes afterwards, after the data has been gathered and the proof of concept has been developed. Considering also training, engaging with the local and regional institutions, implementing applied technology. When we say applied technology, it could be to the level of artificial intelligence, but perhaps consider other natures of technology, since the complementary will bring together a much more comprehensive response to the needs of an environment, conducting with analysis, gathering the feedback, disseminating, and perhaps consider a higher next stage. So having said that, my presentation is now completed. I would like to invite you all for my next event, which is going to be in Dubai, where I'm going to be conducting with a masterclass, where the topic focuses on AI for safer roads. So we will be discussing that matter, and it's a very interesting worldwide event that happens not very often. So if this could be something of your interest, feel free to reach out, and I'm pretty sure that I will be able to help you and perhaps meet you in person. Thank you very much for your time today.
Okay, thanks, Leila. So thanks for sharing the components that is important to ensure the roads transportation safety. So let me share my screen now to share the results of the poll. Can you all see? Yeah. Can you guys see the results?
Yes.
Okay, yeah. So it looks like human plays a very, very important role besides technology and also the environment as well. Yeah, because I think human factors do affect, like, for example, how the AI is being developed, because like what Dr. Susie said, it needs to be tailor-made, and also how we want to optimize for the urban mobility as well. Yeah, so yeah, thanks to the participant for participating in the survey. So we see that as shared with both panelists, that collaboration and innovation is very important for us to build the cities of the future. So, and we need to include both local and international stakeholders as well. So I want to pass to Sarah and Zoa. Can you share your experience, based on your experience managing so many international projects, how the community can collaborate internationally?
Many thanks, Dr. Chong. First of all, really a great pleasure to be here with all of you, and many thanks for the invitation for João and myself to present today in this AI and Smart Cities event. So greetings to the other panelists and also to the different participants. So I'm a member of the board of SPI, so I'll give you first an overview of what is SPI, and then João will go more into the smart cities topic. So starting with our presentation, the topic will be innovation, pilot projects, and international partnerships. That's one of the core areas of SPI. So we are basically a private company, a consulting company that has a focus on science, technology, and innovation. My father started the company in '96. He's the president. We have 85 full-time consultants. And basically, SPI started being inspired by the Green Book for Innovation from the European Commission, being an interface between the private sector, the universities, the research institutes, and the international organizations, including the European Commission, the World Bank, the Asian Development Bank, and other international donors. So we have right now 85 full-time consultants from different nationalities and different backgrounds. We also have consultants from Southeast Asia. We have 2 interns right now with us from Nanyang Technological University in Singapore. We have consultants from Indonesia, from Nepal, not yet from Malaysia. So we look forward to having also consultants from Malaysia. And in terms of our locations, our headquarters are in Portugal, in Porto, where João and myself are located. We have other offices throughout Portugal. We are in China and the USA already for more than 20 years, since 1999. So we started our internationalization process 3 years after SPI got started. We also have a company in Spain, and then a strong activity in Brazil and Latin America, Africa, and Southeast Asia. So we are very active across different Southeast Asian countries. So we have 3 main areas of acting. We have the area of innovation, the area of science and technology, and also the area of territorial development that João is in charge. And within this area, we are quite busy all the time working with different projects for different types of clients. That can be startups, SMEs, universities, business associations, clusters, science parks, all the area of municipalities, and then working with the World Bank, Asian Development Bank. We just won a contract actually in ASEAN with the Australian aid, dealing with SMEs, and then working a lot with the European Commission. So 2 examples of projects we have been involved that also tackle Southeast Asia. EURACCESS is a project about mobility of researchers. So we want to give all the information about research opportunities in Europe, and people from ASEAN can have access to this. So all the access to the now Horizon Europe program that has a funding of 100 billion euros, all the access to Marie Curie, to the ERC grants. So all types of funding can be available from Europe, also open to Southeast Asia. And this program, EURACCESS, that has also a chapter in ASEAN, also with a focus in Malaysia, also Singapore, Indonesia, and other countries, has many events that promote the opportunities for researchers to allow them to interact with the funding opportunities in Europe. So if you need more information, you can also contact me for that. Another project, this took place in Singapore. So basically, we had a mission focused on the mobility goes international. We took a group of companies to participate in the smart mobility and automotive SMEs and startups, together with a big event that took place in Singapore. So this also allowed the connection between Europeans and Southeast Asian participants, and this had a focus on these automotive SMEs and smart mobility. So another initiative that we were involved in promoting connection between the EU and ASEAN. So I'll pass now to my colleague João, and from my side, I remain available for the questions and answers. And also you can contact me anytime after this event. My email is Sara, altogether, Medina @spi.pt. I'll also put in the chat, and you'll have also in the last slide. And you can also contact me anytime for the future cooperation. Many thanks again.
Hello, everyone. So my name is João Medina, and as Sarah introduced it, I am the manager of territorial development team in SPI. In SPI, we combine
João, you
two
need to
aspects.
put the camera. Your camera is off.
Let me check, because just a second. Can you see me? Because in my screen, it's okay.
The camera is on right now. Just now the screen is off. Yeah.
And now sharing screen. One second. Is it okay now?
Yeah, perfect. Sim, tá.
Okay, so as I was saying, in SPI, we combine this international approach to local analysis of the realities. So working with the urban development, we have experience in different cities and different regions around the world, trying to bring this international view to all the projects that we develop. As an experience, and this comes to the point of the presentation of today, when we talk about the smart cities and technologies applied to city, we see that the concept of city and the approach of city varies a lot according to region we are working for. Just in these slides, these are cities where I worked directly in the previous years, and we see Beijing in the first, in the top left, then Luanda on the top right in Africa, in Angola, Bragança in Portugal, and Natal in Brazil. And as we can see, challenges and realities in different cities are quite different. And so even when we are talking about international artificial intelligence or technology or smart city, we have to be aware of the differences that we can combine in the different cities around the world. It's completely different according to the GDP per capita, the population of each city. We are talking about millions of people in Beijing, and we are talking about 20,000 people in Bragança. So approaches can have to be different when you're talking in different cities. Same thing relates with mobility. Challenges in mobility, questions in mobility are quite different when we talk in different cities. When you're talking big cities in Asia, when we're talking European cities, even different sizes of European cities, challenge in people requirements in terms of mobility are quite different. And so we cannot be talking about technology to serve all problems of the cities in the same way. Despite these differences, the issue of smart cities and bringing technology to the development of solutions for the cities and for the people of the cities is a priority worldwide. We can see that in most of the world we have initiatives related with smart cities, but how to deal with this when the concept of smart is different everywhere, when the concept of city is different everywhere, is a challenge that we have to face when we work for these different regions. Even when I was saying, when we face, I want to be a smart city, as we see almost all over the world, cities preparing their smart city strategies. A few years ago, we were talking mostly about technology. But even in the poll that we made today, we have seen that technology is not the center. The center is this human factor. And so there must be a combination of technological and non-technological issues in order to develop a smart city. That is the approach that is being followed by top organizations around the world about how to develop not only the smart city, but the livable city. So cities where it's nice to live. And this implies a very strong combination of technology and not technological aspects in terms of urban planning, in terms of low carbon infrastructure, in terms of investments in the city. So there is a complex approach and systemic approach that needs to be followed when we talk about issues in the cities and when we talk about specific aspects of city management. This applies overall to the smart city, but it applies also to each vector like mobility. And this is a message that is important from the experience, and the experience in different parts of the world is the part of the combination between technological and non-technological issues in mobility, in resilience, in decarbonation. It's a strong message nowadays. Another message is that these approaches are considered to be a priority for all the European Union, and you see that the European Union program on research, the Horizon Europe, has a line specifically focused on climate neutral and smart cities, where all these issues of mobility can be found, and where they are mostly associated with this climate neutral objective for the European Commission. The last slides that we have brought for the presentation are related with a project that is part of the Horizon 2020 program. That is the project ENRICH, that aims to establish a network between the European research and innovation centers. In this case, in the United States, there are programs like ENRICH in other regions of the world, in Asia, in China, in Brazil, in Africa. And I brought this one because it has a particular issue focused on new trends of mobility. And so trying to approach Europe and the United States in terms of research, there was a study developed on automated driving. And this study collected most of the research areas that were related with automatic driving. And this goes from artificial intelligence to other related issues like big data, cyber physical systems, cybersecurity, wireless communication. And the project went to a deep analysis, developed a deep analysis in the United States ecosystem, trying to find who were the top research centers in these areas and what were they doing, and that was relevant to establish bridges and connections and links with the European centers. So many agencies and state agencies were involved, and the examples that we brought for this presentation are the last four related with state initiatives. The first one was in the state of Colorado, and it's called RoadX, and it focused on infrastructure. So what is being developed in the initiative RoadX is to think about what is the infrastructure of the future. What is how can technology solve the infrastructure challenges that Colorado has? And so this initiative focused on roads, infrastructure related with mobility. The second one is in the state of Florida, that as a program related with the automated vehicles, but this is not focused in infrastructure, but in education. And how can we spread knowledge from basic school to higher education in terms of dealing with automated vehicles? And so there is this initiative, Florida Automated Vehicles Program. Third one, and I will talk about 4, is the Michigan Mobility Initiative. Michigan is very strong in terms of automotive industry, and this project was focused on putting 28 existing facilities working together to test and manufacture smart mobility technologies. And so they want to make the automotive industry the most developed in the world. And so they are working, creating this kind of network of research, trying to bring the best knowledge in the world to this Michigan Mobility Initiative. And the last one is the Ohio 33 Smart Corridor. And this is a kind of a living lab focused on the road, and that is to put state universities and research center working, I would say again, in a mix of infrastructure and mobility systems in order to make Ohio one of the leaders of the United States movement in smart mobility. These were the 4 examples that we brought for the presentation today. But going back to our overall presentation, I would focus on this. The international approach and knowledge of different realities makes us believe that there is a strong need for a mix of technological and non-technological aspects in terms of developing smart solutions for cities, either in mobility or in other aspects. And we believe that creating partnerships and networks of that can participate in these international projects and in programs it's a good way to be in the front run of the mobility issues around the world. So thank you for your time, and please feel free to contact us, myself, or Sarah Medina, with questions about the presentations or other issues about SPI's activity and our projects around the world. Thank you.
Thanks, Sarah and Zoe. Okay, yes, we do have quite a number of questions by the participants. So let me start with a question by Sudha. So far, the AV in Malaysia, is it focusing on the cars, or are there any other formats such as mobility bus or other AV vehicles? I believe Dr. Susie actually did provide a very short answer for that. Do you want to elaborate more on your answer, Dr. Susie?
Yeah. Thanks, Sudha, for the question. I think that's a very good question. I think in recently the test bed was extended to 10 kilometers. So I think the test is still in the prototype mode. I haven't really seen that the AV is already tested on the real world, in the real road, like in Singapore or in Australia, for example, or even in some other country. So then the connection with or interaction with other road user is quite limited. Yeah. So just to answer that question. Does it answer your question, Sudha?
Okay, thanks, Dr. Susie. Yeah, so There's another question for Zora. So basically, Sudha asked, he read, he or she, Sudha read about the porter bus drivers being tracked on a pilot. Sorry about that. So she read about the porter bus drivers being tracked on a pilot with IoT sensors to check their stress level in the roads to understand the road conditions. So based on your experience, Sarah and Zoe, do you see IoT sensor data being used to tie to human in smart cities planning?
Maybe I can talk a little bit about that. The message would be that IoT is one of the vectors and one of the technologies that needs to be brought to the equation, but it's not the only one. And for that, there is a sentence that I don't know who used that is, technology can provide the answers, but we need to know what are our questions. And that is the major problem. Why do we need technology? What for? What is our problem? And is the technology the right way to solve it? And that is a key challenge for the different cities around the world, because in some of them, and it doesn't depend only on the level of the development of the country or of the city. Even in developed countries, in developed cities in Europe, sometimes the most suitable answer to a problem is not the application of technology. It's a kind of hardware, or even there is a trend all over Europe right now that is called the nature-based solutions, trying to make cities more resilient in terms of climate change. And so sometimes we bring, I would say, green solutions to the city. And some other times they can be combined with technology. But I would say that some years ago, we think on technology will solve everything, like all the traffic issues, all social issues, all the energetic issues. And the trend now is much more the combination of different vectors, different approaches, but having clear what are the problems that we want to solve in our cities.
Okay, thanks. So there is a question from Leila. In urban transportation planning, the most difficult issue is to predict the susceptibility of human factors as it relates to the urban mobility safety. How will urban mobility leverage on AI to overcome the human problem in promoting autonomous vehicle? You're muted.
Sorry. Sorry. Now, can you hear me?
Yes.
Great. That's a very good question. But actually, when you think about humans, it's quite hard to predict. Imagine that we are in a very good day and we hear very suddenly, all of a sudden, a very extreme news of happiness or sadness in a road environment. How would AI be able to support that? So we are currently at a stage where we developed models, artificial intelligence that can look not into a large amount sets of data, that can look into a smaller scope of data to anticipate events. Are we predicting? Are we projecting? Are we forecasting? That is here the question. So at this stage, the best, or the stage that we can position ourselves, is thinking about having measures ready should a situation occur. So that's more or less how we can think about artificial intelligence to help us, rather than expect that they will give us all the answers. It's just using it as a tool, gives us results, we take measures upon, And from there, we evaluate whether our measures were of help or not. That's where I would come in, and I hope this answers to your question.
Okay, thanks, Leila. Yeah, so just now, so you talk about the difference between Europe, between Asia, how different cities have different definitions. Yeah, and there's one question here is that in urban mobility problems and prospects, it has been differently in different contexts. So the AI has the capability of articulating these diversities in the provision of smart mobility in cities. Or maybe you can share from your experience since you have worked in different region. Do you want to share from that perspective?
Is that question for me?
For Zoa.
Excuse me?
For Zoa.
Okay, so in terms of the different approaches, in SPI, our role when we work with cities is mostly on the city strategy and urban planning, what we would call the urban transformation. And as Leila was saying, and that is quite correct, we use these kind of technologies as tools for our work. Inside SPI, we are not experts in artificial intelligence. We are not experts in research in this area. We bring this expertise to our teams when it is required. And as I was saying, one of the examples we have is that projects on renature urban plans. That it's I will give the example of we are involved in a project, Horizon 2020, that is called Urban Green Up, where we are working in different cities in Europe, in different contexts, in order to have a new approach to urban planning. And one part of that is technology. We see how can we use technology to have blocks with lower consumes of energy. We have technologies to manage traffic, but this is an integrated approach, and that is an important message, that when we talk about urban transformation, we talk about many aspects, and some of them, as Leila was also saying, as they are dealing with human factors, they are not completely predictable. This is not an exact science. This time, some solution can work, in other city can work in a different way. In different contexts, the results can be are different. And that's why these kind of approaches are supported by research programs. We don't have already the solution for everyone. We are testing what can be solutions and findings that can have some kind of replication and adaptation to other cities.
Okay, thanks. Susie, do you want to add on?
Thanks, John. Yeah, I totally agree with Joa regarding that. You know, the approach that's been implemented in one cities can be, you know, adopted in other city, but the result will be totally different because of, you know, different context in terms of, you know, behavior and so on. So I think I just come back to my presentation just now. Is it going to be a tailor-made technology, if I can say so? So involving the, you know, the challenge from the human behavior, because a different city have a different challenges as well, and also the technological barrier, especially you know, developing country. So yeah, it's not going to be one for all. That's, you know, it's a tailor-made solution. Yeah. but really good insight from Shara, Leila, and June.
Okay, thank you. Yeah, thank you. Sorry, we are a little bit over time today. There is, yeah, I think we answer all the questions from the attendees. Yeah, thank you very much to the attendees for all the questions, the valuable questions. We hope, yeah, before we end, we do hope that you can provide us the feedback through our feedback forms so that we can improve further. We do hope that you enjoy the events as well. Yeah, so we are going to post this in the chat, the link in the chat so that you can see. Yeah, so yes, thank you to everyone. Thanks to all the panelists for the insightful sharings, and also thanks to the participants for participating in the questions. We will upload the video in a week's time, so do keep in touch. For those who require the certificates, we will email you after you submit the feedback forms. Yeah, thank you everyone. Thanks to Sarah, Leila, Susie, and also Joel. Thank you.
Yeah, nice to meet
Thanks.
you all.
Many
Yeah.
thanks to all.
Nice
Maybe
to
we
meet
can
you
take
too.
we could take a group picture, Sean.
Oh
Yes.
yeah, we can take a picture.
Picture.
Good idea. True pleasure.
Okay, 1, 2, 3. Okay, thank you very much. Thank
Please
you.
keep
you
in
very
touch.
much.
Okay.
Yeah, keep
Thank
in
you.
touch. Yeah, yeah.
Let's keep
Okay.
in touch. Thank you very
Bye.
much.
Thank you. Bye bye.
Goodbye.
Bye, bye.
Bye bye.
Stay safe. Yeah,
Bye
bye.
bye.